the focus of this video is reviewing angle vocabulary because that is kind of the first step in this standard. If you don't know the vocabulary, you're going to struggle to set up the equations efficiently. You're going to struggle to pull the definitions for the proofs. So this is really like the main thing that you need to know that opens all their doors. I'm so sorry. All right, so vertical angles. I want you to think, when you see vertical angles, I want you to think like X pattern. Okay, when I think vertical angles, I think something that looks like this. And weirdly enough, if you need like an extra hint, there's a V looking figure in this X pattern, and that V is what I transfer to vertical. So there are vertical angles all over the place, but I'm going to highlight one set right here because I see an X. So there are two sets of vertical angles in that highlighted portion. And just by look alone, you can see that B is congruent to H and A is congruent to C. And that is by vertical angles. So some examples here are A and C and B and H. Okay? So vertical angles, think X pattern. All right, so if we continue this fun journey, let's talk about, let's talk about a linear pair. So a linear pair must be on a line. So it must be on a line, and they must be adjacent, meaning they have to touch, okay? So there are quite a few here if I were to highlight. I've got AC, BC, GF, DE, and then I could switch directions, AB, CH, D. All of these are linear pairs because they are sharing a side and they are side by side. Linear pair and supplementary go together. Now, not all supplementary angles must be a linear pair, but all linear pairs are supplementary. So that is confusing if you're like, what did you just say? So all linear pairs are supplementary, meaning they add to 180 degrees. But not all supplementary angles are linear pairs because we have different types of angles that add up to 180 degrees but aren't side by side. So this is not a two-way street all the time. Supplementary angles has other roads that go off of it. So let's talk about some of the parallel line vocabulary that we need to review so that you can kind of open the door to other things, okay? So looking at this picture, the first thing I want to talk about is corresponding angles. So with corresponding angles, and I'm going to use lots of different colors here. Corresponding angles, I want you to think about line 1 and line 2 because it's a placement, but like let's say angle B. So angle B is on the top right of line 1. So what letter is on the top right of line 2? And that's D. So B and D would be an example of a corresponding angle. If we stick with that same idea, right, let's go to the bottom right. That would be E and C. So again, it's all about what's on line 1, what's on line 2. Your other pairs are A and G and H and F. Alternate interior angles really comes back to the idea of the inside, right? So if I highlight, think about this being like a parking spot, right? There are only 4 letters that are located in the parking spots, okay? 2 on one side and 2 on the other. So when I think about what angles would be congruent, they must also be on alternate sides of the transversal. So I need to pick an angle. If I pick this one, I need to cross the transversal to get its equal angle. So H and D would be an alternate interior, and then C and G would be an alternate interior. Both are in the yellow in between, and I've crossed the transversal to get to them. Alternate exteriors would be non-highlighted in yellow, and again crossing that transversal. So the examples here would be A and E, and would be B and F. Now I tried to separate these types of angles. So we've talked about corresponding angles, alternate interior angles, alternate exterior angles. And the reason I group these together because these angles are all congruent angles. But the last type is not congruent. Same side interior is one of those examples of supplementary angles where they are not a linear pair. Okay, so this is an odd duck on its own. So same side interior would be in the yellow, but not crossing the transversal, so on the same side. So they would be like here, C and D. So angles C and D will add up to 180 degrees, and likewise, G and H. So I'm hoping this explanation, further breakdown of these angles helped you kind of piece this together. If you have any questions at any time, please do not hesitate to ask.